Okay, now I'm recording. What does it mean to find the square root of a number? You started right. Fix it. What does it mean to find the square root of 25? Equals 25. What you said earlier was what number multiplied by itself equals itself, right? The last itself was incorrect, but equals the radicand. Do we all agree? It is very hot in here. I so hope they don't cancel class now. Hi, good morning, Anna. This is Anurag Katyal. I'm one of the math faculty of the Boca campus. How are you today? Fine, thank you. I'm in CB 202 right now. I don't know if you're aware, but the AC doesn't seem to be working. It's not working in my office and it's not working in the classroom either. Correct. CB 224. It's cool in the hallways, so the hallways are nice and cold, but there's no air running or cooling happening in the classroom itself. Correct. Same thing in my office. It's warm. Thank you. All right. Sorry about that. Uh, I have a bad feeling the AC is broken and now they're going to cancel class. But with regards to retakes, I know some of you signed up for like 7 of them in a half hour. It's just not possible to do that many quizzes in 30 minutes. So please pick like 2, maybe 3. It's not humanly possible to do more than that in a 30-minute span. If we get canceled today, then whatever's happening today is either going to have to move to Thursday or Friday. Be prepared for that. Uh, Thursday, instead of doing one-on-ones, I've decided to make my entire office hours from 11:40 to 3:20 bulk quiz time. So at some point of time, whenever I get a break, I'll put a sheet outside for Thursday for all those times. So if you want or if you need to retake that many quizzes, please like separate times out. There's no sense in trying to do 7 quizzes in 30 minutes. You're not going to be able to finish any of them appropriately. And yeah, the retake isn't just for the sake of taking the retake. You need to do things correctly as well. Fair? Same thing on Friday. I'm going to convert all my office hours to bulk, meaning instead of doing one-on-ones, people just come here, sign up for the sheet outside, sign up with the sheet outside, show up. I'll have hopefully the quiz ready for you. Fair? Okay. What's the square root of 25? 5, because 5 times 5 is 25. Square root of 36? 6. Because 6 times 6 is 6. I'm sorry, 6 times 6 is 36. Square root of 0? 0, because 0 times 0 is 0. What's the square root of negative 25? What do you multiply by itself to get negative 25 as the answer? There's only 2 choices. 5, but 5 times 5 is what? But that doesn't work. What about negative 5? What's negative 5 times negative 5? It still doesn't work. So how do you find the square root of negative 25? It's got to be times itself. I cannot pick 2 different numbers. That's why I asked, what does it mean to find the square root of a number? It means you have to multiply something by itself to get the radicand. Do we see that there's a problem here? Square root of negative 36. 6 times 6 is 36. Negative 6 times negative 6 is also positive 36. Do we see why square root of negative 36 is a problem? So based on these examples so far, what do you think you can find the square root of? Which types of numbers? Or look at the bottom left. Or 0. I can find the square root of positive numbers and 0. Based on these examples, what does it seem like you cannot do? Find the square root of negative numbers. Fair? That's okay. Question so far? Okay. Could I rewrite square root of negative 25 as square root of 25 times negative 1? Can I do that? What is 25 times negative 1? Negative 25. So that seems to be legal, right? Because there's a product inside the radical, what can I do? Someone saying it. Say it. You can split it. Now, what's the square root of 25? And then I'm left with the square root of negative 1. I don't know what that is. Because 1 times 1 is what? 1 times 1 is 1. What's negative 1 times negative 1? Also 1. So I don't know how to get negative 1 out of this. What if we do the same thing with negative 36? Could I rewrite this as 36 times negative 1? Yes, no? Because I have a product inside the radical, can I do what Cameron suggested, which is just split them? It's the product property of radicals. I can do that. It's legal. What's the square root of 36? And now notice that we end up getting stuck with the same exact number, square root of negative 1. What about square root of negative 200? I hope you're seeing a pattern. Could I rewrite this as 200 times negative 1, split it into square root of 200 times square root of negative 1? We should know how to find the square root of 200. How do we do that? Think back to when we started radicals and we had to simplify them. Cannot hear you. You think of your list of squares. What's the largest number on your square list that's less than 200? 196. 196 doesn't go to 200. 169 doesn't work. 144 doesn't work. 121 doesn't work. How about 100? Does work. So can I rewrite this as 100 times 2 times the square root of negative 1? Now, this is where we really used the product property earlier, didn't we? We rewrote 200 as 100 times 2, and then didn't we split that radical? So could I do exactly that again? Square root of 100 is 10. So in the past, if we were just simplifying square root of 200, wouldn't we have stopped here, 10 radical 2? But we still have this stupid little thing stuck there. Yes? So with all of these problems, what seems to be the common factor? No pun intended. Where do they all get stuck? The square root of negative 1. Yes? Story time. Detour, but we'll come back to finishing these questions. Kindergarten. What do you learn how to do in math? Like first things, baby steps. What do you learn how to do? Sorry? Count. One. Where do you learn how to count? Starting which number? Start with 1, right? 1, fingers and toes. Those are called the natural numbers. Natural numbers start with 1 and then go up by 1 over and over again. 1, 2, 3, 4, blah, 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 forever. The very first number system that was created was just the natural numbers, things that you could see in nature. 1 sheep, 2 sheep, 3 sheep. Fair? What did you learn to do with natural numbers? Maybe first grade. Add them first. So if you add 2 natural numbers, so pick any 2 natural numbers you want, what is their sum always going to be? It's going to be a larger natural number, right? 1 plus 3 is 4, larger. 10 plus 30 is 40, larger. What do you learn how to do with natural numbers after you've mastered addition? However, which question will you never have in a subtraction problem when you're like learning how to subtract? You guys might be too far removed from this. You won't have negatives and you won't have 0. Kids start crying when you tell them about 0. Because the only way you can explain that is you have 5 toys. I take away 3. They don't like it, but how many do you have left? 2. That's how you teach subtraction. You take things away. But what happens if you have 5 toys and you take all 5 away? They start freaking out. They don't want to think about the number 0. So it's very, very hard, emotionally speaking, to teach someone about 0. Much less negatives, because what does it mean to have 5 toys and take away 8? You can't. You only have 5 toys. How can you take away 8? So which number system, what do you need to add to the natural numbers so that you can do some subtraction? I'll give it away because I'm short on time. The next numbers are the whole numbers, and the way I remember is they start with a whole. So natural numbers are the smallest sandbox. The whole numbers are a slightly bigger sandbox. Whole numbers start with a whole. From this list, what's missing so that you can do subtraction? What can we still not do with 0, 1, 2, 3? What's 5 minus 8? Do you see negative numbers here? So what do you think is the next level up from natural numbers and whole numbers? Well, the integers. Is that air conditioning or something outside? I don't know if it's a plane outside or wishful thinking that it's air. Okay, so what if you add integers together? What do you always end up with? Like if you add a positive number or a negative number, what do you end up back with? I do feel air. Did it just come on? Thank you, sir. You get an integer. What if you multiply 2 integers? Because after addition and subtraction, learn how to multiply. What if you multiply a positive number and maybe a negative number? But I have negative numbers. What if I multiply 0 with a something else? I get 0. I have 0. What do I not have with the integers? I don't have fractions, because what if we wanted to talk about division? 10 divided by 5 is? I have that. But what about 10 divided by 3? I need more numbers. Do we see how our human natural progression requires us to invent more things, to say, hey, I want to be able to add. Oh, cool. You can add within the naturals and you stay there. What if you want to subtract? We need 0. What if I want to subtract larger numbers from smaller numbers? Crap, then we need integers. So addition, subtraction, and multiplication are perfectly fine within the integer sandbox. But what happens if you want to throw in division? You need rational number. Oops. This is a very fancy way of saying rational numbers are numbers that look like fractions, P over Q. where P and Q are integers. So divide any two integers and you'll get a rational number. But what is Q not allowed to be? Think about where Q lives, because you're not allowed to have zeros in the denominator, remember? You're not allowed to divide by 0. So P can be any integer it wants. Q can be any integer except for 0. So these are all the numbers that can be written as fractions. So now you can add, subtract, multiply, and divide numbers and get a new number. What types of numbers are not able to be written as fractions? They're not rational, but radicals are examples of them. What is that group of numbers called? If you're not rational, my wife would say I am being irrational. And examples of these numbers are like square root of 2, square root of 3, square root of 5, pi, e. There's no way to write these numbers as fractions. So these are off on their own because they're not rational. What happens if you put all of these numbers together in a pile? What do you think this pile is called? No. You've used this phrase before. Maybe you didn't know what you were saying. Ever heard the phrase all real numbers? That's what that is. When I say all real numbers, or when you say all real numbers, you're saying every single rational number, every single irrational number, every single integer, every single whole number, every single natural number, all the way down. All of these numbers together are called the real numbers. Fair? Now, think about, again, kindergarten, you learn how to count natural numbers. Then you learn how to add and subtract whole numbers. Then you learn how to subtract larger numbers away from smaller numbers, integers. Then you learn how to multiply and divide. You need rationals. Then around middle school, don't you learn about square roots? Or at least the fact that they exist? Irrationals. What do all of these numbers together or as a whole get called? The real numbers. Now, based on what you've seen today, like from 5 minutes ago, what is one number I cannot find the square root of? Because I have a negative number right here. I have a negative number right here. I have a negative number right here. But common to all three of those, what's the sticking point? Where do I get stuck? It's the square root of -1. Yes? If I have a friend, that friend is real. What if I tell you about my friend, but you've never met the friend? Then the friend would be someone saying it. Imaginary numbers. Enter I. I for imaginary. I is defined to be the square root of -1. We don't know what it is. It's not a real number. So Descartes and Euler came up with this idea. Initially, it was a derogatory thing because they were like, oh, so it's not a real thing. Oh, what is it, imaginary? And then the name just stuck. Because initially they were kind of upset with people saying, of course, it's just silly. Why would you want to even consider finding the square root of negative numbers? It's not a thing. Then they found a whole bunch of engineering and actual physical applications of imaginary numbers. Then the entire branch of complex analysis was born. So what is I then? Yes.
Is imaginary but ours is very close.
Hosting what? Sure. I am recording. I can share the recording if that's easier. Yeah. I is the square root of -1. Yes. So going back to finish these problems, what will be the answer here? 5 times the square root of -1 means? What is square root of -1? I. So 5 comes down, and instead of square root of -1, what can I replace it with? So the answer is 5i. Fair? This answer, 6 times square root of -1, would be 6. Excellent. This guy, 10 square root of 2 times square root of -1. Well, we typically write the square root at the end. So it's not wrong to say what you said, which was 10 square root of 2i. Typically, we'll put the stuff on the outside, the stuff on the inside on the inside. Does that make sense? So if we have this sandbox that has all the real numbers in it, I can add real numbers and get a real number. I can subtract real numbers and get a real number. I can multiply and divide real numbers to get a real number. What can I not do? What operation do I screw things up with real numbers? Right in front of us. What can I not do? And the real numbers start crying. What am I not allowed to do with real numbers? I can't have square roots, right? Can I take the square root of any number and get a real number? What's the square root of 25? Real number. What's the square root of 36? Real number. What's the square root of -25? Is it a real number? Or is it an imaginary number? So if I take the square root of some real numbers, I get real numbers. But what happens if I take the square root of negative ones in particular? Do I get real numbers again? No, I got to go outside my sandbox. I got to make my tool chest bigger. So what's on the outside of real numbers? Complex numbers, which is the title of the section. So what do complex numbers introduce? They throw in an I. That's the entire contribution of complex numbers. So if you take the real numbers and you throw in an I, now that number is called a complex number. Now, this doesn't stop here. If you continue on in mathematics, after complex numbers are hypercomplex numbers. And after that, they're quaternions. And then this just keeps going because there are problems that you just cannot solve, even with complex numbers. So for us, for our purposes, we will restrict ourselves to complex numbers. Oops, no, too far. If I have I equals the square root of -1, there's a second definition of I. What happens if I square both sides? What would I get if I square the left-hand side? I squared. How do we get rid of a radical? Don't we isolate the radical and square both sides? Isn't the radical already isolated? So if I square both sides, wouldn't that give me I squared equals, what will be the square root of -1 squared? So there are two definitions of I. I is either the square root of -1, or said slightly differently, you can say I is the number you square to get -1 as the answer. Does that make sense? Now, I'm going to say something and I'm not going to write it down because you need you guys to pay attention. Are you allowed to divide by 0? Are there any circumstances where division by 0 is legal? No, not allowed to divide by 0, no matter how much you get paid, doesn't matter what day it is, doesn't matter what your name is, you're not allowed to divide by 0, period, end of story. Fair? Can you find square roots of negative numbers? Exactly. It's a bad question I've asked you. It's an incomplete question. So now I will phrase it appropriately. Can you find the square root of negative numbers and get a real number as the answer? that's a hard question, right? Or that's an easy answer to a hard question. So can I take the square root of a negative number? Question mark. Yes, I can. I did. Didn't we take square roots of 3 negative numbers? Negative 25, negative 36, negative 200. So can I do it? Sure. But can I do it and get a real number back? No. Do we understand the nuance between the two questions? So is it possible? Yes. Is it possible and always guaranteed to get a real number as the answer? No. But if you do take the square root of a negative number, what are you guaranteed to get every single time? Not a real, but a complex number. Fair? Now, so far, I haven't really told you what a complex number is. Here it is. So I is just the imaginary number, but the whole thing isn't an imaginary number. I by itself is the imaginary unit. But if I have 4i is not an imaginary number, it's a complex number. So complex numbers are numbers that look like a plus bi. A and b are both real numbers. A, the thing without the I, is called the real part because it doesn't have an I attached to it. And bi by itself is called the imaginary part because it's got an I attached to it. Are we okay so far? Yes, yes, yes. Okay. Now tell me which ones of these are complex and which ones aren't. Let's go one by one. 3 plus 4i. Does it look like a plus bi? Does it look like a real number plus another real number times I? So this is a complex number. What about 3 minus 4i? Does it look like a real number plus another real number times I? No? Because? I never said B had to be positive. So is it a complex number? It is. If it helps you, you can think of this as a plus or minus bi, if it reduces confusion. What about negative 3 plus 4i? I never said a had to be positive. A could be negative. Don't real numbers include negative numbers? So this is a complex number. This is a complex number too. What about negative 3 minus 4i? Because? Can A be negative? What about B? They're both real numbers. Yes, that's a complex number too. No, I can rewrite this as negative 3 plus negative 4i. That's why whether you have a plus in the middle or a minus in the middle, the B could itself be negative and we're safe. What about 1/2 plus 3/4 I? Is 1/2 a real number? Any number you've ever thought about before today is a real number. So is 1/2 a real number? That's A. What's B in this problem? 3/4. Is that a real number? Okay, so does it look like A plus BI? It's a complex number. What about negative 1/2 minus 5/7 I? Also a complex number. A and B could both be negative. We're okay with that. Square root of 2 plus 4/5 I. Is square root of 2 a real number? It's an irrational number, but it's a real number. I'll say again, every single number you've ever heard of before today is a real number. Square roots, decimals, positives, negatives, doesn't matter how ugly the number looks, it's a real number. So, square root of 2 plus 4/5 I, is that a complex number? Yes. Negative square root of 2 over 4 minus 5i. Remember what I just said about it doesn't matter how ugly it is. So is negative square root of 2 over 4 a real number? Yes. You can stick it in your machine and get some decimal value for it. It'll be negative whatever, but you're going to be able to find it. What about negative 5? Is that a real number? This is a complex number too. How about just 4i? Does it look like a plus bi? So is it a complex number? Are you sure? Is 0 a real number? Can I rewrite 4i by itself as 0 plus 4i? So is it a complex number then? It is indeed. What about negative 10i? I can do the exact same thing. 0 minus 10i. Does it look like a plus bi now? Yes. How about 5? Is that a complex number? How about now? Yes or no? What about 7? Every number prior to today was a what? Was a real number. Every number after today is a what? So no matter what number I ever show you, it's a complex number. Yes? Now I'm going to contradict myself. Is this a complex number? I just told you, no matter what number I show you after today is a complex number. So is that a complex number? It's a number. I'm showing it to you, therefore it's a complex number. Is it a complex number in standard form? I haven't uttered those words yet. A complex number in standard form must look like this. It must be a number by itself, plus or minus another number by itself times I. In this definition of the standard form, is there a fraction available? Like, does it say a plus bi all over c?
Um,
3 plus 4i over 5. So how do I write that number in standard form? It is a complex number, but it's not in standard form. So how do I write that number in standard form? You just split the fraction. 3 over 5 plus 4 over 5i. Now, does this look like a plus bi? Anytime you write a complex number, you must present it in standard form. So is every number you have ever seen as of today, or as of now rather, a complex number? Yes. But is it guaranteed that that number is in standard form? No. Questions? You're obligated, anytime you answer a question with complex numbers, you must write your answer in standard form. Questions? Okay, this should go a little bit faster now. What are things you learn how to do in this course? When I teach you a new expression or about a new number, we add them, subtract them, multiply them, divide them. So you do the same thing with complex numbers as well. How would we add these two complex numbers? If you just had to guess, what do you think would be the reasonable thing to do? You're adding. Oh, distribute the positive. I see what you mean. Sure. I don't know. Is this what you meant, Michaela? Or were you trying to do that? Sorry? Then I spoke too soon. You're right. I thought you meant you wanted to FOIL. My mistake. Okay, now what do you think would be a reasonable thing to do? Can we combine the real part with the real part and the imaginary part with the imaginary part? Nothing revolutionary there. So what would be the answer? 9 plus 13i. Done. Just like polynomial addition. Get rid of parentheses first, combine like terms, you get your answer. What do you think we would do with a subtraction problem? Distribute the negative, so 2 plus 3i. Tell me what to write. Combine the real part with the real part, combine the imaginary part with the imaginary part. So what do we get? I heard a -5 minus 7i. Easy enough. Just a callback to things we've done in the past. Multiplication moves more or less the same way, but there's going to be a little twitchy thing that happens. What do you think you would need to do with 3i times 7 plus 10i? If you had to guess. You do distribution. So 3i times 7 plus 3i times 10i. Now what? I heard a 21i. 3 times 7 is 21. 30i squared. In the standard form of a complex number, a plus bi, were there any I squares in it? Is this a complex number? Any number you see is a complex number. Is it a complex number in standard form? No, I need to get it there. If you leave me this as the answer, it's incorrect because it's not in standard form. How do I get it there? Sorry? What does that mean? Factor it? What was the second definition of I? What is I squared itself? So can I replace this I squared with -1? So this would give me, I'm going to run out of space here, 21i minus 30, right? Now is it a complex number in standard form? Nope. Does it look like a number plus or minus another number times I? No, it needs to look like that to be in standard form. So how do I rewrite this in standard form? I think I heard -30 plus 21i. You just rearrange the term so that it looks like a plus bi. Easy? What do you think we do with the guy on the right? Two times 7 is, so you're just foiling. 2 times 7, what's 2 times 10i? 3i times 7? 3i times 10i? But what is I squared? So this becomes 14 minus 30 plus 20i plus 21i, right? All I did was I replaced this I squared with -1. Yes? Now, can I combine the real part with the real part and the imaginary part with the imaginary part, which would give us -16 plus 41i. Is that a complex number in standard form? Problem's over. Easy? Nothing should seem revolutionary here. You're adding, subtracting, and multiplying just like you do with polynomials. Nothing crazy is happening. The only added step here is that negative I squared gets replaced with -1. Fair? Now we get to the fun part. Division is not like division of polynomials, but it is division like something else. Hopefully you'll be able to see parallels here. So 2 plus 3i over 7. Is there an I on the bottom? Just like square roots, you're not allowed to have i's in the denominator because the standard form is a plus bi. No i's on the bottom. Is there an I in the bottom for the first question? So then all you have to do is what? Sorry? I don't know what that means. Say it. Yeah, all you have to do is split the fractions. 2 over 7 plus 3 over 7i. Does that look like a complex number in standard form? So you're done. That's all you have to do. What about the next problem? Does it have an I on the bottom? So I can't just split it because I'll end up with an I on the bottom. I need it to be on top. What if this, instead of this I, this had a square root of 2 here? You didn't have an I. What would you have done then? I don't want square root of 2 on the bottom. So how do I get rid of it? Do we remember? Sorry? Multiply by root 2 over root 2, right? What's square root of 2 times square root of 2? Wouldn't that get rid of the radical? What's I times I? Which is? I don't want i's in the bottom. So instead of multiplying by square root of 2, what do you think I could do here instead? What if I multiply the top and bottom by I? You would distribute the I into the numerator, which would give us what? Plus 3i squared over, what's 10i times I? 10i squared? Well, what are all the I squares really? So can I rewrite this as 2i plus 3 times -1 over 10 times -1? Well, if I just rewrite this, wouldn't this be 2i minus 3 over -10? Just multiply the negative ones. Do I have an I in the bottom? Which means I do what now? Just split, because I need it to look like a plus bi. So if I split this, I'm going to get 2i over -10 minus 3 over -10. Can we simplify these fractions or reduce them? We're at 2 over 10. So wouldn't this be -1/5 I? Yes, no? Did I lose the room or are we all together still? Okay, what's a -3 divided by a -10? What's a negative divided by a negative? Does that look like a complex number in standard form? Not yet. One step away. What do we do? Rearrange into does that look like a complex number in standard form? Looks like a number plus or minus another number times I. Are we okay with that? Cannot hear you. For what? Because what's a negative divided by a negative? We what? I cannot hear you. I'm not saying you're wrong. I can't hear you. Yes. Okay, what's -2 divided by -5? Cannot hear you. Well, yeah, what is the answer? That's just you repeating what I wrote. What's a negative divided by a negative? So what's the answer? We are dividing. We're dividing a negative by a negative. We're not dividing the 2 and the 5. Here's another way to think about it. Isn't -2 the same as -1 times 2? Isn't -5 the same as -1 times 5? Now can I get rid of the negative ones? So we are dividing. Just because we're not doing anything with the 2 and the 5 doesn't mean division's not happening. It's happening between the negatives. Fair? Other questions? Okay. What did you do when you had 2 radicals on the bottom? When you had something like this. And I needed to get rid of the radicals on the bottom. When we had 2 terms. What did we do? We multiplied by the conjugate, didn't we? Which was the same term, but with the opposite sign. Why do we do that? So that we could use the difference of squares formula. So if you have 2 terms here, what do you think you're going to have to do? Of, which would be, yep. Now let's see what happens. Don't worry about the top. We'll get to that in a bit. We'll worry about just the bottom first. Isn't the denominator a difference of squares, a plus b times a minus b? Yes, no? So what's the formula for a plus b times a minus b? You guys are in deep doo-doo if you still don't know your formulas. Yes. So apply that to the bottom. With 7 plus 10i times 7 minus 10i. 7 squared is 49. Minus 10 squared is 100. I squared. Right? Everyone agrees? Why is this beneficial to us? Why does this get rid of the i's in the bottom? What's I squared? Haven't we gotten rid of the i's in the bottom? Do we see that this is the exact same thing we did to try to get rid of radicals in the bottom? When we had square root of 2 on the bottom, didn't we multiply top and bottom by square root of 2? And when we had 2 terms, didn't we multiply by the conjugate? Because I is really what? At its core, what is I? So what is it? Did you say -1? No, it's not. It's the square root of -1. If I were -1, I wouldn't need to create an I. Yes or no? The reason why we're doing the same thing is because I is just a square root. So everything we did with square roots still applies because that's what it is under the hood. We just stick a label of I on top of it, but I is just a radical. So we're not really doing anything new today. All we're doing is just labeling I as square root of -1. That's it. So finishing this, What happens on the bottom? 49, what's I squared? Plus 100, because I squared is -1. 100 times -1, I'm sorry. -100 times -1 yields +100. Which simplifies to 49 plus 100 is. What about the top? Because I need to get it to look like a complex number in standard form. What do we do with the numerator? What are we doing? Just multiplying, foiling. So the numerator would be 2 times 7, which is 14. Keep going. So 2 times 7, 2 times -10i is -20i. Which cleans up to I squared is -1. -30 times -1 is +30 over 149. Which cleans up too, because it still doesn't look like it's in standard form. I's got to be here. I need to have a fraction by it. So it's got to be a number. It's got to be a 1. So questions? Yes.
So like, this and what like where one is movement.
Yes, because it's not in standard form. Standard form requires a number plus or minus another number and then I by itself at the end. The I is not part of that second number. I is sitting there at the very end. So just to repeat what Catrice asked, this would be correct on your quiz. If you wrote this would be marked incorrect because that is not in standard form. It's got to be the real part A plus or minus the imaginary part B and then an I. It must be in that form. If not, it's not in standard form. Questions? Stretching or question? Okay. Do I do this? Let's do it. It's easy. What is anything to the 0th power? I heard a 0, I heard a 1. I don't know. What's anything to the 0th power? It is 1. What is anything to the 1st power? So I to the 1st power would be. What is I squared? That was the second definition of I. Do we remember? Things that's got a star next to it. What does it mean to cube something? Multiply something by itself 3 times. So could I say that I cubed equals I times I times I? What does it mean to multiply something by itself? You're squaring it. So can I rewrite 2 of these together as I squared times I? Am I okay to do that? What's I squared? So can I rewrite this as -1 times I? Or negative I? So what's I cubed then? You got to memorize these four. This will be the easiest question on your final exam. I cannot give you a question that's easier than this. Here's what the question says. Everyone grab your machine because we're going to have to do this live. I will ask you that. I to the 534. Grab your machine. By the way, friendly reminder to those of us who are not here on Monday when I shared the practice test. Only calculator allowed on the final is TI-30X2. Can you raise it higher, Michaela? If you have that, it's approved. If you don't have it, ask me ahead of time and I'll either say yay or nay. There are some scientific calculators that will simplify radicals for you. You're not allowed to use those on the final. So if you have one that no borrowing of calculators, I don't have any. There's one that sits here that Niobe is using. I don't know that it's even useful for you. So make sure you're only using the approved machine. Okay, take 534, divide it by 4. What do you get? What do we get? I don't care about the 133 part. I care about the decimal part. Oops. Can I say 0.5 is the same as 0.50? How many quarters in that many cents? That means this will be the same as I squared. Powers of I repeat every 4. So if I were to ask you what I to the 4th would be, what would you say? It repeats every 4. Sorry? 1. What will be I to the 5th? I will be I to the 6th. -1. I to the 7th. And what about I to the 8th? This is called a 4 cycle, means every 4 powers of I, you're going to start the same cycle again. What about I to the 9th? I to the 10th? I to the 11th? Okay, do me a favor. Divide 8 by 4. What do you get? What's 8 divided by 4? 2 whole numbers, right? No decimals. So how many quarters do you have if you have no decimals? No change. You go to the store, you give them $10, and something costs 8. How much money are you getting back? $2. Are you getting any change back? How many quarters are you getting back? None. So I to the 8th is the same as I to the 0, 0 quarters, which is 1. I to the 9th. Divide 9 by 4 and tell me the decimal part, not the whole part. What do you get? You should get 2.25, yes? I don't care about the 2 part, I just care about the 0.25 part. 0.25 is how many quarters? That means I to the 9th will be the same as I to the 1st, which is, yes? What about I to the 10th? Divide 10 by 4 and tell me the decimal part. Should be 2.5, which is the same as 50 cents, right? How many quarters in 50 cents? So I to the 10th will be the same as I squared, which is, how about I to the 11th? Divide 11 by 4. Should get 2.75. How many quarters in 75 cents? So this would be I to the third, which is, and notice that all of these answers are exactly what I told you at the beginning. That's the point I was trying to make. It's a 4 cycle. That's why we're dividing by 4. What if it were a 5 cycle? Then you divide by 5. What if it's a 17 cycle? Divide by 17. So what if you have I to the, I don't know, 2150? What do you do? 4. 0.5, which means how many quarters? So this giant thing will be the same level as I squared, which is -1. What about I to the 7777? So I to the 25 cents is 1 quarter, and what's I to the first power? Do we understand what I mean by you have to memorize these first 4? If you don't know those 4, then you cannot answer this very, very simple question. Yes, no? Maybe one more for the road. What about I to the, I don't know, 10,000? Divide 10,000 by 4. Think about what the remainder is. I to the 0, there should not be a remainder left over, which means now one of these things is wrong. Actually, 2 of these things are wrong. You guys are taking photos. What's the very first one supposed to be? But no one said anything. You're just taking photos and writing things down. What's the second one supposed to be? I to the first power is I. It's not 1. What's I to the 0th power? Pay attention. Don't just take photos and write things down. Divide 10,000 by 4. What do you get? Do you have a decimal? So you have no change. No quarters coming in. So the quarter number is I to the 0 is. Questions? I can't hear you. I will try to post it as soon as I, oops. I'll try to post it as soon as I can.